Hello students, welcome to this video lecture on the paper Analog and Digital Electronics. This is the subject for BTech Computer Science and Engineering third semester students. My today's topic is on shift register counters, that is mainly two types of shift register counters, ring and Johnson counter. Myself Gaur Gopal Jana, Assistant Professor, Department of Electronics and Communication Engineering, Greater Kolkata College of Engineering and Management. In my today's lecture, I will discuss basically two types of shift register counters, that is ring counter and Johnson counter. In ring counter, I will first discuss the working of ring counter with the help of a logic diagram. After that, two types of ring counter, that is straight ring counter and twisted ring counter, will be discussed. And in the Johnson counter, the working of Johnson counter and the advantages and disadvantages of Johnson counter and the applications of Johnson counter will be discussed. So students, let us go to the topic. So as I told, ring counter is a typical application of shift register. Ring counter is almost same as the shift counter. The only change is that the output of the last flip-flop is connected to the input of the first flip-flop in case of ring counter, but in case of shift register it is taken as output. Okay, except this, all the other things are same. Here the number of states in ring counter which is equal to the number of flip-flop used. Okay, so designing a 4-bit ring counter, we need 4 flip-flops. This is the logic diagram of ring counter. Here we can see that the clock pulse is applied to all the flip-flops simultaneously. Therefore it is synchronous counter. Okay, also here we can use overriding input. This overriding input is applied to each of the flip-flops. Preset and clear are used as ORI. Okay, overriding input. When preset is 0, then the output is 1, and when clear is 0, then the output is 0. Both preset and clear are active low signal, that is always works in value 0. Okay, these two values that is when PR is equal to 0, Q is equal to 1, and when clear is 0, Q is equal to 0, these two values are always fixed. Okay, they are independent with the value of the input of flip-flops and the clock pulse also. Now the working of a ring counter. Okay, here this ORI is connected to preset in flip-flop 0 and it is connected to clear in flip-flop 1, 2 and 3. Okay, thus the output Q is equal to 1 is generated at the flip-flop 0 and rest of the flip-flop generate output Q is equal to 0. Okay, thus this output Q is equal to 1 at flip-flop 0 is known as preset 1, which is used to form the ring of the ring counter. Okay, this presetted 1 is generated by making ORI low, and the and that time the clock becomes don't care. After that, ORI made to high and apply low clock pulse signal as the clock is negative edge triggered. Okay, after that at each clock pulse the presetted one is shifted to the next flip flop and thus form a ring. Okay, so we can observe it from this table. Okay, here we can say that this one is shifted after getting a clock pulse, and as the clock pulse is negative edge trigger, so after getting a low clock pulse, this one is shifted to next flip flop and form a ring. Okay, so here we can see that there are 4 states. Okay, that is 1 0 0 0, 0 1 0 0, 0 0 1 0 and 0 0 0 1. After that it will repeats, that is 1 0 0 0. So in this way we can design a 4-bit ring counter using 4 D flip flops. Now the types of ring counter. Okay, there are 2 types of ring counter, that is straight ring counter and another one is twisted ring counter. Okay, the straight ring counter is also known as one shot counter. In this counter, the output of the last flip flop is connected to the input of the first flip flop, and the main point of this counter is that it circulates a single 1 or 0 bit around the ring. Okay, here we use preset to the first flip flop and clear for last 3 flip flops. And another type of ring counter is twisted ring counter. It is also known as switch tail ring counter or walking ring counter or Johnson counter also. Okay, it connects the complement of the actually this will be the complement of the last flip flop to the input of the first flip flop. Okay, and it circulates a stream of ones followed by zeros around the ring. Okay, here we use clear for all the flip flops. Okay, this clear signal for all the flip flops. This is the timing diagram of ring counter. This timing diagram explains that the clock signal changes the output of every stage of the counter, so that clock signal will help the data to circulate from one flip flop to another. Okay, as the 4-bit ring counter, that is 4 stages and 4 flip flops, as this 4-bit ring counter circulates the preset digit within one clock signal, the output frequency of each flip flop is 1/4 of the main clock frequency. Okay, and this is the state diagram of ring counter. The state diagram denotes that the position of the preset digit, in this case preset digit is 1, is changing its position from LS bit to MS bit for one clock signal. Okay, so this is the state diagram of ring counter. Now the advantages of ring counter: it can be implemented using D and JK flip flops. It is a self decoding circuit, and disadvantage is only 4 of the 15 states are being utilized. Now the Johnson counter. Okay, the Johnson counter is a modification of ring counter. In this Johnson counter, the inverted output of the last stage flip-flop is connected to the input of the first flip-flop. Okay, if we use n number of flip-flops to design Johnson counter, it is known as 2n bit Johnson counter or mod 2n Johnson counter. This is an advantage of Johnson counter that it requires only half number of flip-flops that of the ring counter uses to design the same mod. Okay, same mod number. The main difference between the 4-bit ring counter and the Johnson counter is that in ring counter we connect the output of the last flip-flop directly to the input of the first flip-flop, but in Johnson counter we connect the inverted output of the last stage to the first stage input. Okay, the Johnson counter is also called twisted ring counter with a feedback. Okay, in Johnson counter the input of the first flip-flop is connected to the inverted output of the last flip-flop. The Johnson counter or switch trail ring counter is designed in such a way that it overcomes the limitations of ring counter. Mainly it reduces the number of flip-flops required for designing the circuit. Okay, again similar to ring counter, the clock signal in Johnson counter is connected to the clock input of each flip-flop simultaneously. Okay, now operation, how it operates. The Johnson counter designed with D flip-flop as shown here. It has 4 stages, 4 flip-flops connected in series type of cascaded. Initially 0 or null is fed to the Johnson counter, and on applying the clock signal, output will changes from 1000 to 1100, and then 1110 and 1111 and 0111 0011 0001 0000 in a sequence, and the sequence will repeat for next clock signal. Okay, so the Johnson counter produces a special pattern by passing 4 zeros and then 4 ones, and thus it produces a special pattern by counting up down. This is the timing diagram of Johnson counter. This timing diagram explains that the clock signal changes and the output of every stages of the counter, so that clock signal will help the data to circulate from one flip-flop to another flip-flop. Okay, and this is the state diagram. It indicates that how the data transfer from one flip-flop to another for every clock pulse. The 4-stage Johnson counters are used to frequency dividers by varying their feedback connections. Okay, so they can be used as frequency divider circuit also. And here we can see when clear is equal to 1, Johnson counter starts its operation. On every clock edge, the output of last flip-flop shifts left to the third flip-flop. As the first flip-flop is connected to serial input, that is 1, the input of third flip-flop is 1. Okay, in the next cycle, when the output of first flip-flop is 0, so these 0 rotates in ring form in second half cycle. Okay, so Johnson counter has 4 sequences, that is 8 sequences, that is 0 0 0 1 0 0 1 1 0 1 1 1 1 1 1 1, after that 1 1 1 0 1 1 0 0 1 0 0 0 0 0 0 0. Okay, now the advantages of Johnson counter. The Johnson counter has same number of flip-flop, but it can count twice the number of stages the ring counter can count. It can be implemented using D and JK flip-flop. Johnson counter is used to count the data in a continuous loop. Okay, and another one advantage is Johnson counter is a self-decoding circuit. And disadvantages of Johnson counter doesn't count in a binary sequence. Okay, in Johnson counter more number of states remain utilized than the number of states being utilized, and the number of flip-flops needed is 1/2 the number of timing signals. It can be constructed for any number of timing sequence. And what are the applications of Johnson counter? Johnson counter is used as a synchronous decade counter or divider circuit. Okay, it is used in hardware logic design to create complicated finite state machine. For an example, ASIC and FPGA design. And another application is that the 3-stage Johnson counter is used as a 3-phase square wave generator, which produces 1200 phase shift. Okay, it is used to divide the frequency of the clock signal by varying their feedback. Okay, so these are the applications of Johnson counter. Now these are the references used in this video lecture. Now if you have any difficulty to understand any portion of this video lecture, or if you have any question in mind regarding the topic discussed today, you can contact me through this email IDs, or you can put your question through this email IDs. Okay. So thank you. Have a nice day.